Today, we're going to discuss a capture method of creating 3D models for the use case of e-commerce. Now, as we go through this, we'll show you various use cases of using your 3D model on your website or in your mobile application. This will give the consumer a chance to see your product from various different angles that may not have been achievable through just traditional photography. So instead of taking photos from many different angles, we can reposition this 3D product at the perfect angle. So with that, let's get right into it. In this step, we're going to show the capture process of extracting out the details for 3D model textures. To do that, we're going to first place our item inside of our capture device. We're going to do one full revolution on this side. We're going to take the product, rotate it, record another full revolution, and then finally, we're going to take the product, rotate it, and do another full revolution. After this, we will take all three videos and extract out the textures. These will be combined with our scan data to ensure that we get very high quality textures along with very high quality geometry. In this step, we're going to focus on scanning our product. Now, I'm using the Artec Leo in HD mode. We also sell the Artec Spider, which is another fantastic solution for this particular subject. So, with our subject on the platform, we're going to go ahead and back up at an appropriate distance and begin to scan our product. Now, I have a screen on the back of my device so I can kind of monitor the distance. You may be using a laptop or an external monitor. Just make sure that you're at the proper distance and begin to scan your product. So we're going to go ahead and scan our product and just kind of let it spin on the turntable. And then we're going to pause. We're going to rotate our product. We're going to begin to capture data from this side as well, just like in our previous video for capturing the textures. After letting that go a full revolution, we're going to go ahead again and pause, flip our product, and record the data from this side as well. Now, those of you that use Artec Spider and Leo, you know that distance is important, so make sure that you're staying at an appropriate distance when recording your product from multiple angles. After this is done, we're going to take the 3D scan data that we just recorded off of our Leo, and we're going to process that into a high quality mesh. We're then going to go ahead and combine that data with our previous video capture data. We're going to merge those two together to produce a very high quality 3D model that has fantastic geometry and great textures.
Now that we're done processing our data from Artec Studio, we're going to go ahead and enter into a software called Adobe Substance 3D Painter. Think of it as the Photoshop for creating 3D model textures. Now, Artec has already provided us with a texture and we'll be using that, but one of the steps that we need to do prior to entering into this software is a process called optimization. Sometimes it's referred to as decimating the model. So we're going to decimate the 3D model that comes out of Artec, and then we're going to generate a normal map from that. Now, why do we do that? The reason why we do this is because typically when you get an asset out of Artec, it's about 2 to 3 million polygons. And that's just far too much geometry to display on a website or on a mobile device where a lot of these products will be shown. So if you're looking to put 3D models in a storefront, you need to make sure that your 3D assets are somewhere between the range of 50,000 polygons to 100,000 polygons. And that translates roughly to 5 megabytes to 10 megabytes. Anything beyond that is just too heavy to put multiples on a web page. And this is why Artec scans typically go through a different process for engineering and become very hard to work with when you are using an Artec scan for something like e-com, which is what we'll be using this 3D shoe for. So the process that you do, and you can pick your software of choice to do this, but you're basically going to take the 2 million polygon file that comes out of Artec, and you're going to reduce the polygon count down to something like 50,000 to 100,000 polygons. From there, you're going to generate a normal map, and the normal map is going to simulate the original detail from that 2 million polygon scan or higher, and it's going to let you project that detail back onto a lower polygon model, maintaining the detail but reducing the polygon count. So think of it as a detail skin that you put over the top. So right now you can see that we've optimized the Artec scan, and it's very low quality. You don't really see very many details inside of it, and that's the way that we want it. This is a very lightweight file now. And what we're going to do is we're going to come over here to the paint bucket, create a new layer. We're going to select norm for normal map. And we've already generated that normal map here, so we're just going to go ahead and plug that in. And now you can see that the detail is restored. All of that detail from your scan is in here. And this is what we're going to use to represent the model. So now we have an optimized model where the polygon count is very low, but the detail is very high. And like I said, there's multiple ways of doing that and multiple softwares. We won't be going over that today. The assumption is that you will do your research and understand the process of doing that and how that would work into your pipeline. But every studio and every team has their own software package that they like to use. The software package I like to use is 3D Coat. It's just because it's pretty straightforward and simple for me, but others use ZBrush and some use Blender. Okay, so now that we've generated the normal map, the next thing that we need to do is we need to apply some other maps here. Now, I've used AI to generate what we call a roughness map, and the roughness map is going to simulate the properties of the texture, meaning if this shoe is in real life, how would the fabrics react to real light? How would plastic react to real light? And that is translated through what we call the roughness map. So we've already done that, and again, I won't go over how to generate those. We have our own special secret processes that we use, but we're just showing the capabilities of an asset once it pushes through the full pipeline and how good can we get it to look. Okay, so we've already generated the roughness map, and I'm just going to go ahead and create a new layer, and we're going to name that rough for the roughness map. There we go. Rough. Perfect. Okay, and then we're going to go ahead and just drag this roughness map in here, and you can see the shininess has changed. Next, we will add in what is called an ambient inclusion map. And the ambient inclusion map is just going to create additional shadow detail. That can also be created in your software package of choice. We've done it inside of this software. So in this software, you can basically go to a setting called Bake Mesh Maps, or you can hit F8, and then you'll just select ambient inclusion, and it'll bake that ambient inclusion into your project. We've already done that, so we're going to go ahead and create a new layer. We're going to go ahead and turn on AO. That is the short name for the ambient inclusion, and we are going to basically just drag that ambient inclusion map here, and you can see that it adds in the shadow detail. And this will basically show, when light hits this product, how does it impact the cavities. So we need to have all of that. This whole process is called PBR, or physics-based rendering. It is the only way to get your 3D model to look as real as possible when used inside of a renderer or real-time renderer online. And this ensures that when light hits your product, it bounces off of the fabrics or the textures as if it was really there. So we've created the AO map. And the last thing that we need to do is go ahead and plug in our color. So we're going to come to the very bottom of the layer stack. I'm going to click here. And we're just going to click color. Okay, right there. I'm going to grab our color map from Artec and pop that right in. And now you can see that we have the color as well. So why do we use a software like this? The reason why we use a software like this is because this particular software allows us to do very many clever things. We can change the stitching, or we can change the fabric properties of this 3D model as well. If we need to have a different kind of mesh material or cotton material on the inside, we can apply that, and I'm going to demonstrate that really quick. So I'm just going to come over here, type in fabric, and let's just see what pops up. We've got many different fabrics. I've been working in this software for many years, so I have lots of different fabric textures. Just for the sake of this particular project, we're just going to grab a generic denim fabric. We're going to slide that over to the top of our product. Okay, you can see now that our whole product has been covered in denim. We can go ahead and adjust those properties of that denim to make the textures bigger or smaller to simulate what that denim texture may look like. Okay, so we have this here. And why did I want this denim fabric? Well, I want it to be applied to the inside of the shoe and not the rest of the shoe. So now that we have the denim fabric selected, we're going to go ahead and turn off the color. Okay, the color is now turned off. And then the last thing that I want to do is create a mask. Just like in Photoshop, we have masking here. So I'm going to go ahead and apply a black mask. And now we can go back in, selecting white paint, and paint in the denim fabric texture that we like. And you can see how that is appearing on the shoe itself. And this is going to add that note of realism that we require to really make your product look real. Sometimes when scanning, these details just do not show up. It's just not possible with the scan technology of today. Now, maybe in a few years, scanning technology can not only produce a really high quality 3D scan, but also fabulous textures. But even still, you might want to come back in and let's say that you want a prototype for a new product that you have not yet created. This will give you the chance to test different kinds of fabrics and simulate those onto your existing product, even before that product has been manufactured. So here you can see that I'm adding in that denim fabric to many different areas of this shoe. Okay. And the wonderful part about this is that we can go back through after the fact and adjust the properties of this. And what I mean by that is, let's say that the denim fabric is just a little bit too large. We want to adjust that size. Well, that's easy. We can just come right back over to our layer of denim fabric. We can come up to tiling, and if you watch me change the slider, we can change the properties of that fabric. Sometimes we can also come into an area here, UV projection, and we can change this to triplanar and even this out just a little bit better. And then I can go back to adding in that area that I like. And you can also adjust the pressure. So if you're using a tablet like myself, you can have pressure sensitivity and do a slow build up to that fabric texture as well. We can go ahead and switch our view to see the cutout of our product. And here we can see it in more detail. And what you're looking at right now is a part of the 3D model called a UV map. If you have your UV maps done custom, like we have, it allows you to look at it in this view. Again, that's going to be up to the team that you're working with, and if they implement this into their pipeline. Many do, but not all do. Sometimes, depending on the client that we have, they may request that we do custom UV maps so we can easily change the fabrics. Other clients say, well, we're not going to change the fabrics and we just want that 3D model. Okay, so we have that here. We can also apply some of that texture to other areas of the shoe. And then sometimes if we want to apply it to the laces, as you can see, that can be done there as well. And again, we have other options, so we can go ahead and we can pick plastics or rubbers to go ahead and apply that to the shoe as well. And this will give us a new sense of realism as well. So we go ahead and we create a plastic layer. And again, we can just go ahead and turn off the color because we don't want the color. We want to keep the color that we already have. But we may want to add in a little bit of realism and texture to the bottom of our shoe. So you can see here I'm adding in just a little bit of texture to the base of this shoe. And that will allow us to put back in a little bit more of that realism. So again, we'll change down that size to just a little bit, like so. This is probably pretty good, right about here. And we'll go ahead and put a mask back on it, black mask, and paint in with white. And we can add that all right back in here. And what that's doing is it is adjusting our normal map and our roughness maps that we've already imported. It's adding to them. So we use AI to generate them but then we go back in through hand and we can customize them to further realism. So we can look here at our roughness, and you can see that when I paint, it's adding in not only the roughness values of that plastic, but also the normal map details of that plastic. How raised is that plastic? It has a bumpiness to it, and we want to simulate that bumpiness to make it look real. So we can go ahead and look at our normal map, and you can see here that I'm adding in additional detail. Now let's take another look at this. So if we go back to our color layer right here and turn it off, you can see here that even when I go back to my normal map layer, let's go ahead and find that one. I believe it is here, and I should probably name that. And if we turn off that normal map layer, you can still see that the additional detail that I've gone back in and painted with additional fabrics now show up. So it's a combination of the normal map that you've created and the normal map that you are now creating real time in this software. So this allows for a lot of flexibility to create that realism that we desire. And then after you have your 3D model created in here, you can do many different things. One of the things you can do that I like to do is copy this layer. This is our color. We're going to call this color 2, and this is just color. And we're going to go ahead and turn off the original. We're going to go ahead and add a filter, and we're going to do an HSL, hue, saturation, and levels. And from here, we can change the values of the product. So if like you had a product that was blue and it needed to be red, you would be able to make those modifications here. Or if the shoe needed to go to a black, you could do that in this software as well. And again, it works on a layer system. And so because it works on a layering system, we can go ahead and turn it completely off, or we can just add a white mask and paint back in the areas that we want to have remain white. So that could be these areas as well. By contrast, we could go ahead and turn this whole layer to black, turning it off, having our original color, and coming in with white paint and adding black back to the areas that we would like to have show up. So now we've switched to a white paintbrush, and we can change those values completely, as you can see here. So that is the power of using a software like this. Like I said, it's basically the Photoshop of 3D. Now from here, we're going to go ahead and export as a GLB. And a GLB is a great format for using on Android. It is something where it's universal, works on Windows, allows you to take that GLB and put it right inside of PowerPoint. It also imports into Blender very well. And if you have the iOS plugin, you can export as a USDZ. And the USDZ is a wonderful format to use on iPhones and iOS products. And this will allow you to basically email your 3D model to your client, or even text message it if you're on iOS. So that is a brief run through of how we do post-production and why we use post-production and the various softwares that we use. Please reach out to us if you'd like to know further information, and we can kind of go through the processes with you for your particular 3D model. Shoes have a whole different process, as do bags and other assets, but they ultimately end up in this software at some point in time, and we do post-production on the coloring, the textures, all of those things to produce a very realistic 3D model.
So to summarize, we have captured our video data of our shoe from 3 sides. We then scanned our shoe with the Artec Leo in HD mode, and we processed our data in Artec Studio. From there, we exported, we continued our post-production in our post-production software for texturing. And now you have a complete 3D model of your shoe that is ready for e-commerce use. This can be used on your website or in mobile applications, virtual try-on, and various use cases. Hope you enjoyed our video. If you have additional questions, please feel free to reach out.